Okay, guys, welcome to my second lecture that is on hydrostatic forces on the surface. सरफेस पर हाइड्रोस्टैटिक यानी कि फ्लूइड जब स्टैटिक कंडीशन में हो तो सरफेस पर कैसे फोर्स लगाते हैं इसके बारे में जानेंगे आज। एक्चुअली थर्ड चैप्टर है फ्लूइड मैकेनिक्स का। तो इस चैप्टर में हम लोग क्या क्या पढ़ेंगे इस एक्चुअली इस लेक्चर में, इस वीडियो लेक्चर में हम लोग जो दो चीज़ पढ़ने वाले हैं वो है टोटल प्रेशर एंड सेंटर ऑफ प्रेशर। ठीक है। एंड when the fluid is static then the velocity gradient will be zero. If the velocity gradient is zero then the shear stress must be equal to zero. Then if the velocity gradient and shear stress is equal to zero then the forces, what kind of forces acting on the fluid particles. That first is the pressure of the fluid normal to the surface, that already we are going to discuss in the previous chapter when we started the fluid statics. And force due to gravity, that the two forces which are going to be acting on the surface of any surface. Okay, now when these forces are acting on the surface then the thing is that what is total pressure and the center of pressure, where these forces are acting and how it is acting. Then the total pressure, it is defined as the force exerted by a static fluid on the surface. Force exerted by a static fluid on the surface, either plane or curved, when the fluid comes in contact with the surface. जब कोई फ्लूइड किसी सरफेस के कांटेक्ट में आता है, स्टैटिक फ्लूइड के कांटेक्ट में आता है, तो उसके सरफेस पर अगर वो प्लेन हो या कर्व सरफेस हो, उस पर वो फोर्स कैसे लगाता है, वो प्रेशर कैसे एग्जर्ट करता है। तो फोर्स तो हमें पता है कि क्या होता है कि एक नॉर्मल टू द सरफेस फोर्स लग रहा होगा, एक ड्यू टू ग्रेविटी जो सेल्फ वेट ऑफ द फ्लूइड पार्टिकल उसके चलते फोर्स लग रहा होगा। ओके, this is called the total pressure. Then the next thing is that center of pressure. What is center of pressure? Then it is defined as the point of application of total pressure on the surface. Point of application of total pressure, यानी कि the point where the total pressure is acting, appear to be acting on the surface. Okay, and this point is called the center of pressure, just like in a center of gravity. Okay, it must be similar to that center of gravity and center of pressure, but actually this is different, similar, not exact. Okay, now next we are going to be study, it is also there in your syllabus, that the total pressure force and center of pressure for different plane surface. We have to find out the total pressure and center of pressure for the different surfaces, just like vertical plane surface, horizontal plane surface, inclined plane surface, and curved surface. Okay, these four I'm going to be covered in coming slide. But the first one, the vertical plane surface, I'm going to cover today only. The vertical plane surface when submerged in a liquid. Just look at the diagram. This is a surface. Figure 3.1, it is shown as the surface, a surface, any random surface which is submerged in a liquid, in a fluid. Okay, then we have to take a strip of it, a small strip of it, just as we did also in previous explanations and the previous determination. So here also we are going to be determine the what is called as total pressure and center of pressure. Okay, so let us consider what we are going to be considered in this. A is the total area of this surface, the plate we are going to be immersed, the plate which we are going to be immersed in the liquid. the area of that plate is A. Now further, when we are deriving the total pressure and center of pressure, then we will take A as the total area. Okay, H bar. Here is the H bar and H dash. H bar is the distance of center of gravity of the area from the free surface of a liquid. Any center of gravity from the free surface of a liquid is called the H bar. Now G. G is the center of gravity of plane surface. G is the center of gravity of plane surface and P is the center of pressure. Okay. Uh, just just now I told you that center of pressure is similar to center of gravity but not the exact one. Okay. In some cases, further when we discuss about the horizontal plate, then we see the center of gravity and center of pressure is meeting at the same point, but not in this. This is the vertical plane immersed in a liquid. Then the center of pressure and center of gravity is two different point. So the distance of the center of pressure from the free surface of a liquid is assumed as h star. Okay, now we start our derivation. So before starting the derivation, we should know what we are going to be find out in the derivation, what we have to find out in the derivation. So what we have to find out in the derivation, we have to find out the force, the total pressure. We have to find out the total pressure F that is acting on the vertically submerged body and center of pressure that is H star. The H star and F we have to find out. So let us start with the total pressure. Determination of total pressure. How we are going to find out the total pressure? For finding the total pressure, let us take something. We have to take a small strip having having depth thickness is dh and width is b. Okay, then the area of that small strip is dA equal to dh into b. Okay, now the pressure on the vertical plane, what is the pressure acting on the vertical plane? That is okay, draw, I use the pencil over here. Then the pressure P equal to, I know, rho G and H. Let everyone know the pressure equal to rho G H, and the area of the strip that we are assuming, the area, that area dH into B, it's dA, small area is a dA. Then okay, then dA equal to dH into B, that you all know. Okay, uh, pressure equal to rho GH and dA equal to dH into B. Now next dA equal to dH into B and pressure equal to rho GH, we all know. Then the force, what is force equal to? Anyone? Force equal to pressure into area, that is dF. As we are taking the elementary area dA, so we have to determine the elementary force that is acting on the elementary area. Okay, the pressure P into elementary area dA. The pressure P we know rho G and H, and the elementary area is dH into B. So this is the elementary force acting on the strip. This is the elementary force acting on the strip. Now for elementary force acting on a strip, so if we want to find out the total force acting on the total surface, we have to integrate the both. We have to integrate the force we have to integrate the area. If we integrate the area, then we are going to get the total area and the total force. So I'm adding one more slide over here, and now I can write the integration of df is equal to I just take integration of p into dA, that is rho gh into dh into b. For rho gh dh into b, here is the rho and g are the constant term, only variable is b, h and dh. Rho and g are the constant term, only variable is b into h into dh. Okay, now we have to take this integration. Okay, this integration only. Let us see what is going to be happen with this integration. B into h into dh. Okay, that dh into b, we know what is this, dA. Then integration of h into dA. What is this? Integration of h into dA. Integration of h into dA. What is the h? H is the height. What is h? Let us see here. H. H is the height of that elementary area. H is the height of the elementary area, yeah, elementary part on the free surface of a liquid, that is called as H. H. H is the height of the elementary area from free surface of a liquid. Now, what next is, then we can write what we can call as H into dA is movement of the surface area about the free surface of a liquid. We can say that H into dA, we can say that movement of the surface area about the free surface of a liquid. What is the movement of the surface area about the free surface of liquid? Then the area of surface into distance of the center of gravity from the free surface. Area of surface multiplied by distance of center of gravity from the free surface. Okay, see, of integration h into dA is equal to integration of h into dA is equal to let's see, movement of surface area about the free surface of a liquid. Movement of surface area about free surface of liquid. I'm not going to be write that sentence, movement of free surface area about the moment of surface area about the free surface of a liquid. If we integrate that thing, then we are going to find moment of surface area. What is the surface area? Total surface area is A, and so the total surface area is A, and the distance of the total surface area from the free surface of a liquid is h bar. So see here, here df equal to integration of b into h into dh. If we integrate this thing, then what we are going to get, a into h bar. Now f is equal to, we can write rho into g, that is constant, in place of rho g, and integration of b into h into dA, we got a into h bar. A is the total area into h bar is the distance of center of gravity of that area, total area, center of gravity of that total area. Okay, not the center of pressure, is the center of gravity of the total area from the free surface of a liquid. And This is called the total pressure force. Total pressure force acting on a surface. Total force totally acting on a surface. It's solved. Now next we have to determine the center of pressure. How we are going to be determine the center of pressure? Okay. uh, we are going to determine the F is the rho g into A into h bar. Now we have to find out the center of pressure. For finding the center of pressure, we are going to be use the principle of movements. Principle of movements. Anyone remember principle of movements? Principle of movements means the movement of the resultant force. The movement of the resultant force about an axis is equal to the sum of the movement of the component about the same axis. The moment of the resultant force about an axis is equal to sum of the moment of the component about the same axis. Both are equal. The resultant force F, here is the resultant force F, okay, is acting at P at a distance h star, that is the distance of the center of pressure from the free surface of a liquid. Then the moment of the force F about the free surface of liquid must be equal to F into h star. Okay. Now we are going to take an elementary strip, that is dH. So the force acting on a dH is dF into h about an axis, the same axis we are going to follow, which must be equal to dF must be equal to rho gh into B into dH. Oh, let us see. Uh, what I say is the moment, uh, principle of moment. As per the principle of moment, uh, the resultant force about an axis is equal to the sum of all the component of resultant force of the component of force about the same axis. So resultant force about an axis, we are taking the resultant we are taking the resultant force dF, resultant force dF about an axis, that is h. dF is acting on an elementary strip, okay, at a distance h from the free surface. This is the moment. Now moment of all the components of forces, all the component of forces, we have to equate this thing for all the component of forces. Now it's rho into g into h into rho g h into b into dh, b into dh. This is the component of all the elementary forces, different forces component, okay, about the same axis. We have to multiply this force. So I already write this force dF here. I have write dF equal to P into dA into rho g, P into dA. So P is the rho gh into dA equal to dH into B. The same thing I write over here also. The same thing I write over here also, B into dH. Now we have to multiply this total force with H. Then only we have to equate it. The moment of elementary force about the axis is must moment of all the resultant force about an axis must be equal to the moment of all the component of force about the same axis. Now we have to integrate it. We have to integrate, both are equal, we have to integrate it. We have to integrate it. What? Rho g h into b into dh into h. So sorry. So Here also rho g is the constant. We have to get it out, rho g. Then what we are having, h square into b, that we are having h square into b. Then and dh, oh I forgot, dh. Next slide, dh. So let us take equal to rho g into b into dh is dA. B into dh is dA. Then h square into dA. H square, we know the height of the elementary particle from the free surface. Height of the elementary particle from the free surface. Then h square into dA. What we are going to write, h square into dA is the b into h square into dh. Okay. Now h square into dA, b into dh is dA. So b into dh, what, h square. So bh square into dA, that is the moment of inertia, of the surface about the free surface of liquid. What is this? The moment of inertia of surface about the free surface of a liquid. Then we can write this thing as rho g into I naught. Rho g into I naught. From I naught we are going to be represent the moment of inertia of the surface about the free surface of a liquid. Like a moment of inertia. Simply we are going to be multiply rho g into moment of inertia. So what next? Here we are going to be found that rho g into I naught, that is one part, and from where we started, df into h. So integration of df into h. So also I'm going to integrate df into h. Rho g I naught must be equal to df. When we are going to integrate, df is equal to, just a minute, it's df is f and h become h star, because now the elementary area is no more. We have to integrate the elementary area into the total area. Then the center of pressure, we assume center of pressure h star, center of pressure from the free surface of liquid, the distance between the center of pressure and the free surface of a liquid is h star. So now we have to find out the h star. So h star must be equal to rho g I naught divided by f h star must be equal to rho g I naught divided by f. That is called the h star. New slide. Let us see. It's not in over here. And again, h star is equal to rho g I naught divided by f. What is f? What is f? F is the rho g a into h. F is rho g a into h bar. The rho g to rho g cancel. What is left now? I naught divided by a h bar. I naught divided by a h bar. Again, again. What is I naught? I naught, moment of inertia. Then I can write I naught is equal to Ig, moment of inertia about the about an axis. Okay, and Ig is the moment of inertia about an axis passing through the center of gravity. Passing through the center of gravity. I not equal to Ig plus A into H square, H bar square. So we have to replace it in the above, in the previous equation, I naught divided by AH bar. So if we are going to be replace I naught with this, then H star must be equal to Ig divided by AH bar plus Ig divided by AH bar plus uh, H bar. I think I have to show you it again. We have to replace I naught in this equation. We have to replace I naught with Ig into AH bar in this equation. Okay, this equation, in this equation. Uh, we have to replace this thing. I have to replace this thing in the previous equation. This, okay, this equation. Show. Uh, show. Let us see. I have to explain it. H star must be equal to I naught. In the place of I naught, we have to write Ig plus A H bar square divided by A into H bar. So we can write like this. We can write like this. We can write like this. Ig divided by A H bar plus A H bar square divided by A H bar here. Now what we are left with, H star is equal to Ig divided by AH bar plus H bar. This is the final center of pressure for the vertically submerged area. If you are having any doubt, you can ask me. You can contact me on my WhatsApp. Please subscribe my channel for update. You can comment in YouTube also. Thank you.